Hey everyone, and welcome back to my science studio. This lesson is actually part one of a three-part series on chemical composition. Today we'll be focusing on percent composition, so how to find the percent by mass of each element in a compound. Part two, we'll talk about how to find the empirical formula, or the simplest whole number ratio. And part three, we will finish off on talking about how to find the molecular formula. But anyways, let's get started. What is percent composition? Well, percent composition tells us the weight percent of each element in a compound. But why does this matter? You see, it helps us determine how pure a sample is. And it can help us identify an unknown substance. And one thing I love telling my students is to imagine you're a CSI investigator, right? CSI Miami. And you're trying to analyze a mystery chemical at a crime scene. Well, percent composition could actually help you narrow down what that compound actually is. So, how do we calculate it? It's a formula, and it's percent of the element is equal to the mass in grams of that element in a sample divided by the total mass of that compound times 100%. Let's go ahead and walk through this problem step by step, and you'll see how we can plug the values into this formula. So here we want to try to find the percent composition of carbon, hydrogen, and oxygen in glucose, right? C6H12O6. It's a sugar. The first thing you want to do is find the molar mass. And I highly recommend, if you haven't done so already, to go check out my lesson on the mole concept in the event that you don't remember maybe how to find the molar mass. But anyways, so to find the molar mass, the first thing you want to do is to identify how many of each atom you have, and that's given by the subscripts in this compound. So here we have 6 carbons, 12 hydrogens, and 6 oxygens. Now, using the periodic table, so the one your teacher or professor gives you, we get these values, right? So for carbon, we end up getting 12.011 grams per mole multiplied by how many carbons we have, which is 6, and we end up getting about 72.066 grams per mole of carbon. On the periodic table, the molar mass of hydrogen is 1.008 grams per mole multiplied by 12 hydrogens, and we end up getting 12.096 grams per mole. And lastly, for oxygen, the molar mass on the periodic table says that oxygen is 15.999 grams per mole multiplied by the 6 oxygens we have present here, and we end up getting 95.994 grams per mole. Fantastic. Now that we've multiplied across, we can go ahead and take the sum of these values we just found. So taking 72.066 plus 12.096 plus 95.994, we end up getting a total molar mass for glucose of 180.156 grams per mole of C6H12O6. And one quick tip before we continue is try not to round too early. So in other words, don't round as you go, or at least try to avoid it. And the reason is because you want to keep your numbers as precise as possible so that your final percentages, as we'll see in the next step, they add up to a number that's very close to 100%. Okay, so now we're going to go ahead and calculate the percent of each element in this compound. And we can do this by dividing each element's mass contribution by the total molar mass. So for carbon, for example, the total mass of carbon in this sample is 72.066 right? And a common mistake is that students will put the molar mass of carbon by itself, which is 12.011 grams per mole, but that's not right. You have to multiply by the number of atoms present. That's the total molar mass of carbon in this sample. And then you're going to divide that number by the total molar mass of glucose that we solved for, which is 180.156. And then going ahead and multiplying by 100, we end up getting about 40.00%. And I rounded it to 4 significant figures because the number with the least amount of significant figures from the molar masses that I reported was the hydrogen. From my periodic table, it gave me 1.008, so we're going to keep it at 4 sig figs. Now for hydrogen, you're going to do essentially the same thing as you did for carbon. So for hydrogen, the total mass in the sample is 12.096, and then you're going to divide that by the total molar mass, which is 180.156. Multiplied by 100, and you get about 6.714%. For oxygen, the same. So we're going to take the total mass of oxygen, which is 95.994 grams per mole, divided by the total molar mass, which is 180.156, multiplied by 100, and you end up getting about 53.28%. Now, if you add them all up, you'll see that you get a number that's very close to 100%, which tells us that we did something right. Okay, I encourage you to go ahead and pause the video and try these next 2 questions on your own. And when you're ready, press play and we'll walk through them together. So in this question, they're asking us to calculate the percent of hydrogen in H2O. So the first thing you want to do is find the molar mass of hydrogen in H2O and then find the molar mass of water. So the mass of hydrogen is, we have 2 hydrogens present here times the molar mass, which is 1.008, and we end up getting 2.016 grams per mole of hydrogen. So that's essentially our numerator here. That's what we're trying to find, the percent of hydrogen in this sample. So what is the molar mass of H2O, of your total, right? Well, you take this 2.016 for hydrogen and you're going to add that to the molar mass of oxygen. And we only have one O here, so it's just going to be adding 15.999 grams per mole. And you end up getting 18.015 grams per mole of H2O. And so that's going to be in your denominator. Going ahead, we're going to divide 2.016 divided by 18.015. Multiplied by 100, and you end up getting 11.19% of hydrogen, which is telling us that water is about 11.19% hydrogen by mass. That's what this is saying. And a little quick check here, just for fun. If hydrogen is 11.19%, then what do you think oxygen would be? What percentage? If you're thinking about 88.81%, then you're right. It should be. Why? Because together, hydrogen and oxygen should equal 100%. So if you take that 100% and subtract it by the percent of hydrogen that we just solved for, you end up getting what's left, which is 88.81%. Exactly. Okay, and the last question, it's asking to find the percent composition of carbon and oxygen in carbon dioxide, or CO2. So you're going to do the same thing. For the percent of carbon, you have to find the mass of carbon present in CO2, which there's only one C present, so it's 12.011 grams per mole, and divide that by the total molar mass of CO2. So when you add the mass of carbon to the number of oxygens multiplied by 2, right? So it's 2 times 15.999, adding that to 12.011, you end up getting 44.009 grams per mole. divide, multiply by 100, and you should get about 27.29% carbon by mass. And then for oxygen, right, there's 2 oxygens present multiplied by 15.999. So the mass of oxygen is 31.998 grams per mole. Divide that by the total molar mass of CO2, which is 44.009, multiplied by 100, and you should get about 72.71% of oxygen by mass. And together, they add up to about 100%. Okay, and that's percent composition, you guys. In part 2, we're going to be using percent composition to help us find the empirical formula, also known as the simplest whole number ratio of a compound. And then in part 3, we'll go even further and determine the molecular formula. Thank you guys so much for watching. If you found this lesson helpful at all, please don't forget to like and subscribe to my channel. And I'll see you in part 2. But until then, happy studying!